Okay, so is the screen visible?
Yes, sir.
Okay, so same what Swapnil have guide me, same thing I will do. Okay, what guidance he have given me, I will go in CFD software. Okay, let's say ANSYS or COMSOL. Okay, I will go in this software. Then I will build up one pipe. Okay, so this is my hollow pipe. Okay, so then I will add a material. I will do a meshing. Okay, I will give some boundary condition. Let's say velocity I will give u average. Okay, this is of radius ra. Okay, this is the axis. Okay, then I will build up one physics laminar flow. Okay, okay, then I will do a compute and the flow is set up. Okay, so I will do steady flow. Okay, because I am running it for 30 minutes, so of course after 10 minutes the flow will be steady, so I will do steady flow. Okay, so steady laminar flow मैंने built up किया. Now what I will do now, if I want to introduce the water particle, what I will do in the CFD, there is one technique called as particle tracking. Okay, then I will take this module, particle tracking module, and then I will introduce some dummy particles. Okay, some dummy particles I will introduce at the inlet. Okay, this dummy particle may be of density rho, viscosity mu. Okay, I can define. Then diameter of the particle may be 1 micrometer. Okay, so those particles, diameter, density, viscosity, I will introduce, and then again I will simulate my flow, and I have to see that whether this dummy particle they are approaching towards the outlet. Okay, with the help of parabolic. Okay, ये dummy particle, तो ये तो मैं CFD में देख ही सकता हूँ. Okay, so let us go to the software. Now what I have done exactly, I have tried to mimic my experiment in CFD. Okay, simple experiment I will mimic in the CFD. Okay, so let me go in go to my software. Okay, so this was the flow. Can you see the screen interface of COMSOL?
Yes, sir.
Okay, okay, so this was the flow which we have seen that day. Okay, so you can see that the flow through a hollow pipe, हम लोग ने laminar flow उस दिन किया था और हम लोग को ये simulation मिला था. Okay, so the velocity is maximum, you can see at the center. Okay, and velocity is zero, almost zero at the surface. Okay, तो अभी ये distribution कैसे parabolic है कि नहीं, इसके लिए मैंने क्या किया था, I have taken a cut line 3D2. Okay, मैंने cut line 3D2 लिया. Okay, 0.5 पे. Okay, at this point. Okay, I will show you.
Hello, hello, sir.
Hello.
Sir, actually, AnyDex screen is visible, not console interface.
Now, can you see console screen?
Sir, now nothing is visible.
Yes, sir, visible.
What is visible now?
Visible,
Can you tell me?
console screen is visible.
And on console screen, what is there? Which figure you can see?
Pipe figure, sir.
Color pipe, na? With the color
Pipe.
pipe. Yes.
Color
So
pipe.
Pranav,
Yes.
there may be a problem with your internet. Please check once. You can move out of the meeting and then again you can join. Okay, so
Yes, sir.
this was the flow which we have simulated. So velocity was maximum at the center and it was minimum, almost zero at the surface. Okay, तो हमारा जो theory से ये valid हो रहा है कि center पे maximum velocity है around this. Okay, ये maximum है और ये कम हो रही जा रही है 5, 4, 3, 2, 1 and almost zero at the surface. Okay, और अगर मुझे parabolic distribution देखना है तो मैं क्या करूँगा, cut line 3D2. Okay, cut line 3D2 में I will make a plot. I have given this dimension x, y, z. Okay, so you can see ओके ये इस पे मैंने कट किया था, ये लाइन, ये सिलेंडर पे, ये सेक्शन पे, और ये सेक्शन पे मुझे देखना है पैराबोलिक डिस्ट्रीब्यूशन कैसे हो रहा है। तो मैंने लाइन ग्राफ लिया, ओके, so line graph I have taken, okay, and I have seen that yes, it is parabolic. Okay, so on the surface it is, zero, and at the center it is maximum. Okay, now let us take cut line. अगर मैं एकदम नीचे करता हूँ, okay, if I am taking it at 0.1, okay, let's see what is the nature at 0.1. 0.1 मतलब एकदम मैंने कट प्लेन नीचे लिया जहां इनलेट है. Okay, now let's check how the distribution will be. So let me delete this first. Okay, then I have to take line graph. In line graph, cut line 3D2. Okay, plot. Okay, still it is coming parabolic. Okay, so at every section it is coming parabolic in nature. Okay, now let me take cut line 3D2 little more down. Okay, 0.01 I will take 0.01. So still it is parabolic in nature. Still it is parabolic. Now let me take it at 0, 0. Z is 0. Everything is 0 now. Both the Z is 0. Okay. This is why, because the flow is what? Steady. I have established the steady flow inside my solver. Okay. So मैंने steady response दिया है, time response. इसलिए मुझे वो parabolic मिल रहा है. See, at 0 also it is getting a parabolic. Okay. Now let us verify this by using the particles. Okay, whether I'm getting same thing. So in add physics, we have to go for fluid flow. Fluid flow is the module. Under fluid flow, particle tracking is there. Particle tracking for fluid. Add to component. Is this screen visible? Have you seen I have selected particle tracking module?
Yes, sir.
Okay. So particle tracking module I have selected. Okay, I will reduce this. Sorry, I will increase this. So now see, this is a particle tracking module. The symbol for this is, representation for this is FPT. This is the entire domain I have selected for particle tracking module. What are the equations we have used? The equations are simply what? D by dt of m into v. Mp is what? Mass. Okay, mass of the particle into velocity. Dv by dt is what? Acceleration. Okay, so particle tracking module is purely based on Newton's law of motion. F is equal to mass into acceleration. Okay, and formulation, whether it is a Newtonian, non-Newtonian of first order or massless. तो मुझे Newtonian particles लेना है. Okay, real maximum number of particle if I am taking let's say 10,000. Okay, so now there is a wall. ओके वॉल के लिए कंडीशन रहेंगी फ्रीज करना है वॉल के लिए. पार्टिकल प्रॉपर्टीज, ओके पार्टिकल प्रॉपर्टीज हियर दे हैव गिवन. सी द डेंसिटी तुम चेंज कर सकते हो 20. यहाँ कितनी डेंसिटी है, कैन यू रीड? व्हाट इज द डेंसिटी ऑफ पार्टिकल, डमी पार्टिकल?
2200.
Yes, 2200 kg per meter cube. Diameter is 1 micrometer. Okay, यहाँ तुम दे सकते हो particle type, solid particle या liquid droplet bubbles. So you can give solid particle, no problem. Okay, initial charge number is 0. Okay, now in particle tracking for fluid, you have to select what should be the inlet. Okay, the inlet. Okay, so inlet is this. Yes or no? So this is the inlet. So I've selected inlet 3. Okay, inlet is 3, release time is 0. Okay, we will have the mesh based density random. Okay, so according to the density we will have. Okay, according to the density we have. Okay, after selecting the density, we are supposed to select number of particle per release. So let's say select the number of particle per release as 100. Okay, then density proportional to 1. Okay, density proportional to 1. Number of particle per release, let's say 100 particle हम release कर रहे हैं per ये user define. So according to velocity field, है ना, मुझे क्या करना है, ये पार्टिकल पैराबोलिक में लाना है. तो मैं क्या करूंगा, वेलोसिटी फील्ड के साथ कपल्ड करूंगा मैं ये पार्टिकल, तो ही वो पैराबोलिक में आएंगे. ओके, सो आइदर वेलोसिटी फील्ड अगर तुम 0 दे सकते हो इनिशियल, या फिर इट शुड फॉलो दी वेलोसिटी फील्ड. ओके, वेलोसिटी फील्ड ऑलरेडी हम लोग ने सिमुलेट किया. ये पाइप में कौन सा फ्लो है, अभी लैमिनार फ्लो है. ये ऑलरेडी मैंने सेटअप किया. एक्सपेरिमेंट में मैंने क्या किया, 30 मिनट्स मैंने फ्लो चालू रखा. तो आफ्टर 10 मिनट्स ऑफ कोर्स देयर इज अ लैमिनार फ्लो बिल्ट अप इन दी पाइप. वैसे ही मैंने सीएफडी में मैंने क्या किया, पहले लैमिनार फ्लो बिल्ट अप करके लिया. अभी मैं क्या करूंगा, नाउ व्हाट आई विल डू, आई विल इंट्रोड्यूस द डमी पार्टिकल. नाउ सिंस द लैमिनार फ्लो इज ऑलरेडी बिल्ट अप इन द पाइप, okay, after introducing the dummy particle, that dummy particle should follow what? Okay, it should follow the velocity path. So I am specifying it as velocity field. Okay, velocity field. Okay, that is velocity field. Okay, so inlet I have given the boundary condition. Okay, this is the boundary condition I have given. Okay, then I will go for again I have to select the outlet. Okay, so again I will go to particle tracking and I will have the right, I will click right click, then I will have particle counter, where the particle counter should. Okay, so I will take particle counter. Particle counter should be at the outlet. Okay, this is the outlet. Okay, so particle counter will be 4. Okay, the outlet boundary condition. Okay, so all. Okay, release feature is from where it is releasing, from inlet it is releasing. Okay, so the particle are releasing from inlet and it should counter at what, the counter should be at outlet. Okay, so release should be from inlet and outlet should be at the particle counter. Okay, so I have taken inlet, outlet. Okay, then I will again take I will add a study. Okay, time dependent study I am adding, so that I will come to know कि ये particles कौन से time में बाहर आ रहे हैं. Okay, because I want with respect to time, at suppose I am giving 100 particle here. Okay, at what time my 50th particle is coming out, or at what time my 100 particles are coming out. So if that graph I want, I will select time dependent study. So add study. Okay, in add study you can give some time. Okay, let's say I'm giving 250 as my time. Okay, I want to do the simulation from 0 to 250 seconds, and my time period is interval is, let's say, 10 step. Okay, 10 step में मैं ये करूँगा, forward करूँगा iteration. So 0 पे मैंने start किया, 250 till 250 I will do the computation. 10 is the step period. Okay, replace.